Okay. So brief info of sir. Sir presently working professor and dean. Dean Academics in SGGSIET. He completed graduation in civil engineering from Government College of Engineering, Aurangabad. He obtained his master's degree from very prestigious institute, IIT Kharagpur, and PhD from Roorkee. He has teaching experience of 34 years, and he has published more than 50 journal papers in reputed international and uh, journals and conferences, and having H index 6, I-10 index 4, and citation more than 300. He has guided 5 PhD students, and he is BOS of SRTMU and Amravati, Jalgaon, Mumbai University. He has organized one international conference and 7 plus QIP courses. He also undertaken various central funded projects. Recently, he completed GST fees project of 80 lakhs. One more thing I want to highlight here. So this course is possible due to his support and effort, and he is very cooperative and always supportive to young faculty like me. So with this brief introduction, I will start the video.
The video lecture is organized around all these points. Criteria for source selection, especially.
Okay, wait, I will play in other mode.
Points. Criteria for source selection, especially for rural water supply system. Then what can be the possible sources of water in case of this RWS. Then I will try to explain protection of the system developed from contamination, simple treatments for rural water supply. Then we will discuss about things related to rural water supply.
as far as water is concerned, as we say, it is life, and then if it comes to the rural population, which constitutes about 50 to 60% of our Indian population, we need to provide good quality water to them. That is the mandate. And integration, all governments have made efforts from the good quality water to the rural populace. But the major effort started with the sanitation program sometime in 1984. And then a lot of investment was made in the rural water supply and sanitation because it was felt that the pressure on the health system, especially from the point of view of rural population, was tremendous, and most of the diseases were attributed to the contamination. People were not able to get good quality drinking water, and then most of the diseases were attributed to the drinking water problems. Therefore, it was felt that if you want to reduce the pressure on health system, it is worthwhile to provide safe water supply to the rural population. And with that intention, this RWS or rural water supply schemes started getting importance. Then this ambitious program of rural water supply and sanitation started. So, therefore, in various 5-year plans, lot of provision people started making. Now also we know that this ambitious program is being taken up very positively because this population is very large, and then this rural population it is existing in isolated patches. We have to have such schemes which will be able to make available water to almost all households which are located in a vast amount of area. And then obviously we have to take into account from engineering point of view the economy as well. So with this intention we have to look at this RWS from different point of view. The RWS we can study on these accounts, that is criteria for source selection for rural water supply, and which source is suitable. If possible, we have to lift the water, and then we have to also protect the source from contamination, and if possible, we should be able to make arrangements of simple treatments in this RWS. So these are the things which we are going to discuss in this particular video lecture. Let's first discuss the criteria for source selection. So while selecting a source of water for rural area, we must give priority to such a source which needs no water treatment. Further, it should not be pumping also. If such a source is available, that is a wonderful source. But if such a source is not available, then we need to go for detailed investigation for selection of source, and then we have to think of treatment alternatives. We have to think of geological investigation so as to know what is the amount available, and then for these we take the help of old people in the area. Then we also try to see what is performance of the existing sources, especially wells, how much water was available there in the past. Those estimates we can get from information of nearby streams and geological conditions in the area. And then we can also do a little bit of testing of wells, well water, and then get to know what is the quality. That's how one goes into the selection of source. So once we get the information about the site and amount of water available, we can think of these 4 types of alternatives from the point of view of RWS, that is rural water supply. What are these preferences? First preference should be given to water which requires no treatment to meet bacteriological, physical or chemical requirements. And we should be able to deliver this water to the consumers by gravity. If that is the condition, then we say that it is no treatment, no pumping condition. And obviously, we can say that it is the most economical proposition. Usually, it is found that in the upper reaches of the watershed, usually we come across springs in geological zones, and these springs are such sources which will provide good quality water, which will need no pumping and no treatment, so that it can be delivered to the consumers by gravity. The second option is, if this first option is not available, then we can have such a source of water which is requiring no treatment to meet physical, chemical and bacteriological requirements, but we need to pump it so that it is delivered to the consumers. So obviously we need to consider a deep well which is a safe water supply source, and from there we can withdraw water from pumps with the help of pumps, and then again through gravity it will be supplied to the consumers. That is second arrangement which can be done for RWS. Then third is water which requires simple treatment, and again delivery is through either pumped system or through gravity system. That will be given third priority, because obviously economic considerations will outweigh the other things. So once there is a requirement of treatment, it is a recurring expense. So we will think of it as a third option. Then fourth option, if these 3 options, such a water source is not available, but still, as I have said, in national sanitation, water and sanitation program, the aim is to provide safe drinking water to households, so that we are able to release the pressure on the health system, because sometimes investment in this water supply scheme is more economical compared to what you invest in the health system. So prevention is better than cure. Water requiring simple treatment and to be delivered by pumping is the last alternative, because this will be the most expensive amongst all these 4 alternatives. Here we can think water supply from surface sources or water supply from water bodies. Now, after selecting the source, we have to keep following points in mind for ensuring safe water delivery to the consumer. We should have such collection system which will not damage the quality of water, which will not alter the quality of water which is coming into this collection system. Then, if at all treatment is to be given, it should be simple and economical. Because this is a rural area, we may not get experts to monitor all those things. So if the treatment is simple and economical, that will be advisable. Then around the source of water, a depth of 3 meters from ground should be made watertight to avoid entry of pollutant into this particular source. That is protection again. When their public wells are provided, we we better have special drainage system so that this rainwater, which is usually contaminated water after use, it doesn't come back into the source. For that, we have to have, along with water supply system in that particular village, we should have appropriate drainage system also. Now, obviously, in case of springs, we should ensure that these springs are not overexploited and exposed to the atmosphere. Further, while providing drinking water from well, these septic tanks, sewers, or subsurface pits, they should be at least 15 meters away from the well, from where we are withdrawing water. Then sewage and sewage disposal works must be located on the downward slope of the ground, at least at a distance of 30 meters from the well or source, so that all these things do not result in contamination of the water, which is usually used for supplying to the households. Let's now discuss about the sources of water. The primary source of water in case of rural water supply is rainfall, and then we have to understand how does the rainfall occur over a period in this particular region, and then we know that some portion of this rainfall gets converted to runoff as far as hydrological cycle, and some portion percolates into the ground. Okay. Basically, we have to understand infiltration, difference between infiltration and percolation. So, percolation water beyond infiltration is available. So, portion of rainwater percolates into the ground. That is usually available as a source of water for RTWEs. Okay. So, while planning for a source of water for rural supply, we need to ensure that surface flow is minimum. So we have to go for this watershed treatment, and then we will be able to make available water. And then watershed treatment should be said that it should not involve heavy cost of constructing various structures, and then also there is some instances of direct pollution that also should be avoided, so that whatever water is coming to a particular portion or location, it should be free from pollution. Okay. So, at the in case of rural water supply, we mostly rely on groundwater, but sometimes it so happens that the water becomes saline, and then because of the surface condition, and then we find that groundwater is saline water. So in such case, we will go for surface water source. As stated here, in fact, the subsoil sources are the most common and suitable source of water supply in the rural areas, because it is highly reliable in quantity, and as well as we believe that groundwater is usually not having quality issues. And if at all there are some quality issues, the treatment is cheaper. The dug wells are the oldest and most common source of water in rural areas of our country. People relied on dug wells, and if you visit many villages, you find that in state, along with the constructed water supply system, this system is also available. So when properly located, constructed and protected, these are sure to be very satisfactory source of supply of water. Then other subsoil sources are springs, infiltration galleries, rainwater systems, and obviously these infiltration galleries and rainwater systems, they will obviously store water for some more time, rainwater. So before actually constructing the source for water supply system, we need to assess the water requirement in rural population. Okay. So this assessment requirement is based on requirements to be fulfilled and also how much money we are marked for the RTWEs. So we have to find golden mean of this. The requirements may be for individual houses, particular area, or whole locality. It should be considered that here, in case of rural water supply, this particular arrangement is mostly for drinking water, and for other necessities also may be considered for assessment. The guidelines which should be kept in mind while estimating water requirements are as follows. Generally, capacity of one tap is taken as 10 liters per minute, and therefore the quantity required will be number of taps envisaged multiplied by minutes of supply, or how many minutes you are going to supply water. Usually we go, in case of rural water supply schemes, once in morning and once in evening, almost for half hour or 1 hour. So that way you have to count the number of taps for how much time you are running this supply system. That will be able to help us in estimating the requirement. Now, if houses are not having taps, and then if the water is being supplied only by street taps, okay, common taps, so in that case we take the demand as 18 liters per person per day. If you know the population, then so usually we say that throughout the year we should be able to provide the supply, so that way we will be able to find the water requirement of that village, total water. Now, if taps are available, then we will take the demand as 45 liters per person per day. This is usually standard. This is simply enhanced to 60 liters actually. Then, if there are certain public systems like school or dispensaries, etc., for that also we take demand as 45 liters per head per day. In general, in case of the street taps, at least for 200 people, we can have one tap. And taps or water outlets will be such located that water carrying distance should not be more than 100 meters. Otherwise, there will be inconvenience to the population, and sometimes there will be quite a few losses also. Now, table displayed before you is general water requirement criteria for rural water supply. The item hand pumps 45 liter per head per day. Now, pipe supply, including kitchen supply, will increase slightly more because apart from drinking, we believe that it is used for other purposes also. So it will be 75 liter per head per day. Sports 45 is recently I have told you. Sports without pumping 25. Now we have to also consider in case of rural population, livestock water requirement also. Okay, so these are the consumption pattern. For horse, we have to consider 50 liter per animal per day. For dairy cow, 70 liter per animal per day. For sheep, 10 liter. For if poultry is there, for 100 numbers chicken, we will have to have 20 liters per 100 animals per day. Now, we calculate the requirement based on this, and then total productivity should be calculated for 1.5 the present population. Because in case of urban water supply, we go for population forecasting. But here, we don't need to go that extent in detail here. We just like water requirement of 10 as per this criteria and make it 1.5 times. Let's say first source of water, that is springs. Okay. A good spring is obviously sure and safe and reliable source of water, although they are not very common. Springs are found very rarely. And if at all they are there, the upper reaches of a particular village terrain, then they can be very good source of water. But whenever they exist, they are seriously to be considered as a source of water. We should explore them. But before development of a spring, we have to consider following things. Whether the flow is adequate to meet the requirement even in dry weather. Sometimes the springs go dry in dry weather. We have to check. If in dry weather also these springs are lying, and nothing like that. And whether quality of water is also satisfactory. Usually from spring, the quality of water coming is good, but in case of sometimes hot springs or sulfur affected areas, sometimes we don't get good quality water. We avoid springs. Whether spring is located favorably for natural gravity, and if not, whether it would be economically viable to pump the water from the spring. When the spring can be protected, whether we will be able to protect the spring from pollution and contamination. Once it is exposed to this kind of situation wherein we start using it for water supply, then obviously may be vulnerable for pollution and contamination. So can it be protected with ease? That is where we have to explore. And then will it be easier and cheaper to develop the spring than drilling the well? So we have to explore this. If we are needing some developments around the spring locality, then the distance between the spring and the places where it will be supplying water is large. Then we have to think of drilling well in the locality. So we have to just compare this. We find that springs is cheaper, reliable, and go for it. A spring high enough above buildings, and again not too far away from that particular locality, always can supply water by gravity. Wonderful location. What this will do, this will eliminate the cost of installing and running a pump. So an elevation of at least 6 meters is desirable for the satisfactory gravity. Now if the elevation is not sufficient for satisfactory pressure at taps, then what can we do is we can bring the water by pipe to storage tank nearby locality, and then it can be pumped from there. So for that we need small pumps. It can be combination of exclusively the storage near spring and directly supplying water to the households pipe without pumping, or if you find that this it is not sufficient, then we can think of having another underground storage arrangement near locality, and from here we can supply water. The pump cost may be very less. So this particular arrangement, spring supply kind of thing, is shown in the figure before. Now the size of storage tank should be such that we should be able to hold at least 2 days supply of water. Then artesian and infiltration varies. Obviously we can take into account various aquifers, especially the aquifers are what you can say that aquifers which are confined aquifers. So in that we get the artesian wells and infiltration galleries. They have sufficient water that can be also used as source of water. More important is using ponds. Okay. Even though the surface water is last priority, but if we find that springs, infiltration galleries and other things, they are not so reliable, quantity is also less, in that case we have to decide to use the surface water. So in addition to drinking water, it is also needed for other household of work like kettle requirements. In such cases, drinking water is supplied through subsoil water, and pond is considered to cater other needs of the locality. So such kind of conjunctive arrangement we can make. So following are the important considerations before going for a pond. The size to be, size of pond, location, type of pond, and total cost involved in that. So if pond is to be used for limited purpose, it can be small. We can have a depth of about 2.5 meters and should be located near the point of use. But if large volume of water is needed so as to supply water for various purposes, then the size of pond must be larger, and then we have to search suitable location uh, in the watershed so that lot of water gets collected at that place. Depending on that, we will decide the location and size of that particular pond. So for best result, the pond should not be obviously less than 0.5 meter deep, and the catchment area should be several times the surface area of the pond, okay? So that we would get sufficient amount of yield in the pond based on the distribution of the pond. Still, we have to ensure that the evaporation and leakage etc. are occurring, but still we will have sufficient water in the pond, around double the estimated demand of water. Such pond can be constructed, and that will be a very good surface water source for the. Now, the pond should be located where soil is of such a nature that it will hold water, not release water and it will contribute to the groundwater. That kind of thing you cannot expect when you are declaring it as a surface water source. So such soil should have very low coefficient of permeability, and generally it should be clayey in nature. Faulted or porous rock close to the surface source should be avoided. Then earth filled around the periphery of the pond should be well compacted, and it should not have more coefficient of permeability so that you can avoid seepage. Now, in order to fill a pond, it should be located where there is a sufficient watershed or catchment area of 20. A natural source-shaped or cup-shaped area with a small flowing stream from where water can be diverted to the pond is usually an ideal location. There can be 4 types of construction for ponds: surface or watershed ponds, spring-fed ponds, or dugout ponds, or diversion ponds. These details you can get from various literature which is available on watershed development. For example, if you consider surface or watershed ponds, they get water from the surface runoff of rainwater from nearby sloping land. Such ponds are obtained by putting a fill across low point land. The fill or embankment must be watertight and should have a spillway to take care of this water. That is about surface or watershed ponds. Now, spring-fed ponds are built below continuously flowing springs. The usual method is to construct a dam across the spring root. The dam should be well below the spring so that the pond will not flood from the spring. If spring flow is high, then surface water should be diverted. This provides better quality of water and avoids damage of pond by flood. Dugout ponds can also be made by making holes into the fairly level soil where underground seepage water or surface water can flow and fill the pond. Such types of ponds are very common. Then diversion ponds are made where a stream of water is available. So we can have such kind of ponds which can be used as surface water source. We can also construct rainwater system. I'll show you the sketch of rainwater system. This is how this rainwater system will it's like it will be constructed near home or go down, etc. So such is the area. We get to collecting water will be there, and from this collecting area we will be directing water into the underground system. Walls which are made up of bricks. This is the arrangement of system here. You can see here. These are watertight walls which are plastered from both ends, and have this overflow arrangement. Then from here we will be able to pump the water. Okay, and water which is from root can be diverted into the system. So sometimes this is also constructed of RCC, below ground. kind of arrangements were popular earlier. So underground pump system also can be used. The best type of construction of system is by RCC, located in or near the building. Underground location is the best because it's water better condition and at the same time construction is also cheaper. So these typical types of construction are shown to you already. The next source is a very popular source is well. It has been already pointed out that subsoil water is the best source of water supply for rural areas and then most common and popular source of groundwater. Wells are preferred. We can have around 5 common types of wells: dug wells, driven wells, jetted wells, or bore wells, and drilled wells. So out of these dug wells and bore wells, they are known to most of us. The oldest type is dug well. That is how the dug well looks like. Diameter can be 1 or 2 meter, and then say from 15 meter or 20 meter from top it can be constructed, and below that it is attached so that. Why it is 15 to 20 meter? Because we believe that the groundwater table depth from the ground level maybe around 15 to 20 meter. Now, gone are the days of considering this as groundwater table level, but earlier it was so. So, in order to have some protection, this one portion is constructed and remaining below that portion is kept open so that the water due to water from water table gets collected in the dug well. So this figure shows the dug well. It is a hole of 1 to 3 meter diameter dug into the earth annually until a flow of water is obtained. Then this hole is walled and covered to protect it from surface water. Depth of well varies depending on the flow of water into the ground. Sometimes it is even 15 to 20 meters. So wherever we have this porous strata at shallow depths, we will go for such types of dug wells. The well point is shown in 20.5 figure. So little bit additional type of arrangement, we call it as second type of well, driven wells, jetted wells. So such types of wells are used as a source of water. This is the driven well, and then we also have arrangement of submersibles pumps, etc., so that we will be able to lift the water. Now we have drilling machine, but earlier people were using hand-driven machines for drilling wells. This is called as jetting rig, the bore well. Then let's see something about the lifting of water. Now, if we are going to use the wells, then we have to have provision of lifting. Now, lifting of water through buckets is a very old system. Okay. First, it was just taken out of well by pulling the water filled with bucket with hand, and then rope is connected to that well. Then, in order to later on, we started using some lever system to improve the convenience of lifting the water. And pulley system also helped the reduction of effort in lifting water. Subsequently, a bucket pump was evolved, in which small buckets are attached to an endless chain, and this is rotated over the sprockets, so that each bucket dips into a well water and gets filled up, carries water to the top and empties into a spot as it passes over the top sprocket. So this is simple arrangement. This system became very popular for small ductworks. Subsequently, we started using lifts and pumps. Now we have various versions of pumps, which can be used for shallow depth wells as well as bore wells also. These sketches show those developments in the front of drinking water. Earlier, as I said, this rope and bucket, and then we can have some lever arrangement to ease out the efforts required for lifting the bucket filled with water. Police system, very popular. And then this is the bucket pump. Then we have all other kinds of pumps. Hand pump is also there, typical hand pump. Let us know it. I will not discuss much about these pumps because we are aware of. And we need to protect this water from contamination because prevention is better than cure. So protective as well as preventive measures should be taken to keep the water free from contamination. For RWS, as I have said, groundwater is always safer because it gets natural filtration by percolating into the ground. Now, since groundwater is taken out of wells, we should take care to prevent well water to get contaminated. Following care should be taken to safeguard the well. These are general things. The well should be covered with watertight cover possible. In case of dug wells, where water is taken by buckets, opening of the top should be provided such that outside top water goes into the well. And lining should be provided. We should avoid sewers and other polluting sources around the well. These can be taken care. We can use some simple disinfection treatment options. The extent of treatment of RWS supply depends on the quality of raw water and funds. Most of the rural supply is drawn from the underground, and we expect that it needs minimum treatment. Well water sometimes contains iron and manganese in solution as bicarbonates in the presence of CO2. We can go in such case for simple aeration. The aeration will be able to expel CO2, and then this soluble bicarbonate are converted to insoluble carbonate. We can remove them by filtration. In case of the water which is contaminated by iron and manganese, what we can do, we can go for aeration and filtration. Aeration will expel CO2 and then also interact with bicarbonates and convert them into insoluble carbonates, which we can remove by filtration. So option is aeration and filtration. It is cheap. Now, if water is soft and corrosive due to presence of dissolved oxygen and CO2, water is treated with lime. Very popular treatment, lime by controlling CO2. Because of lime, the pH will get raised to cycle of calcium carbonate. Now, this again insoluble calcium carbonate will give the protective coating to the pipe. Now, disinfection of water supply can be done using chlorine. So these are the options: aeration, filtration, use of such thing lime or chlorine. If there is a bacterial load, then we can go for use of chlorine. Then if there are some simple chemical impurities, we can also go for excessive chlorination, and those can be increased from 0.05 to 0.1. The higher concentration is generally used at the time of threatened water-borne diseases, especially in rainy season. Bleaching powder is also used as a cheap alternative in rural areas. This well water is chlorinated by pot chlorination. The pot will take the chlorine and it will be immersed into the water well. Now, in case of the surface water is having turbidity or polluted to lesser degree, then we can also go for filters, sand filters, etc. Now, in case of uncovered store water, sometimes algae procedure. Now, if it is a blue-green growth, it produces scum and objectionable odor. It is again harmful for cattle. We have to treat this. Usually, we can use copper sulfate solution for arresting the growth of algae. If you look around all these things, you find that in case of rural water supply, we go for treatment either by using aeration or filtration or pH correcting chemicals or use of chlorine, or if beyond that if there is a biological problem like algae etc., then we can think of using even copper sulfate. To that extent, we will be able to treat the water. But if it is going to go beyond that, then better think of other solution and we will be able to solve the rural water supply problem. So friends, in this lecture, I have explained you only simple rural water supply system. Mostly it is conjunctive type of thing. If the kettles are to be given water, then we prefer surface source, and then for households drinking, we prefer well-based water supply system. With this, I'd like to conclude this session with a remark that it is worthwhile to spend a little bit of more money on providing good rural water supply system than to spend a lot of money on health system later on, because 60% of population still is staying in rural areas, and they must be provided with safe drinking water or safe domestic water. Thank you everybody for patiently close this session with your permission.
Okay. Participant, we have 1 hour break. After that, we have one session and followed by a small valedictory function. After that, we will publish a link on email and WhatsApp, so which will be activated for 1.5 hours. So this link include both feedback and examination. So we'll meet at 1 p.m. Sir, message from Dawde sir, Dr. Dawde sir. Sir, when you will share the test link? Sir, after valedictory function, we will share the link.
Okay, thank you, sir.
Okay, sir. Thank you.